Start recording. Our next piece that we're going to add is going to be the flat socket head cap screws. Okay. And those are going to hold our jaw in place. I have one in place already. So I'm going to show you the process of getting that so that it's gonna place where it's supposed to and the correct size. You'll notice that if we go to our assembly and we go back up to our bill of material, this is going to be a countersunk cap screw, a 1/4 by 0.625, which is 5/8 inch long. Okay, 5/8 inch long. So go back to Creo, and we will use that to call out our fastener. So we're going to go to the Tools tab. We're going to go to Screw, and it's first going to ask us to select the position. So we want to select the axis where we want to place it. So I'm going to click right here on that axis. Then it wants to know, where is the head placement going to be? We're going to select this face of our jaw plate. And then where is the back side going to be? So then we're going to go on this side. Now, if you can, you may or may not be able to, if you can select the surface on the back side here, and it seems to be doing it here, but if you can't, you're going to have to hide the base and then go on the other side. So you're going to go like that. And then we're going to hit OK. Don't worry about orientation. Make sure that the catalog is on inch, not on ANSI English. Go to regular inch. And then you want to select the countersunk screw. Countersunk screw. And you want to go down to 1/4. And we want this length to be 5/8 inch long. Right there. And then it's going to give you a preview. Make sure that you click off if there's any nuts or anything like that on the back side. Click off of that. And then you're going to hit OK. All right. And it should place it. Now, if for some reason it's floating above the surface, and this happens once in a while, I'm not sure why, even if you do it exactly the way that we did it, what you'll do is you'll go back in to it. You'll edit that definition. And there's going to be a distance here. Make sure that distance is 0 on the offset. Okay, 0 on the offset. If it's 0 already, you don't have to worry about it if it's nice and flush. So let's do that again. We're going to do that on these two parts over here. I'm going to turn my planes off because they're it's a lot to look at. So our on Tools tab, we're going to go to Screw. We're going to select the center line. Select the surface it's going to start on, and then select that back surface there. Okay. Same thing. It should remember the very last one, inch, countersunk, 1/4, and then 5/8. And then it's going to give you a preview. Looks good. Okay. And I'm going to hit OK. And then I'm going to do it one more time. Remember, we don't mirror anything in our assembly. So don't try to mirror this and think it's going to be okay. Assemblies don't like that. I err on the side of adding them all. So this should remember everything. The preview looks good. And I've got my last one in place. All right. I am going to do a save. Looks good. All right. Now, unfortunately, the library here for the dowel pins it just doesn't work very well for what we have going on. Josh, one of the students in class here, kind of confirmed that as well. I tried it earlier, but we have this spherical end on our handle rod, and we don't have a surface to actually select to actually place it. So the dowel pin is not going to be a great option for doing the pin that's going to go through here. Now, you're going to notice if we look at the assembly itself, I'm going to go underneath my my camera. It's calling out a 000 taper pin, which is a standard size taper pin. Okay. So it's calling out right here. It wants us to drill through. Now, remember on our ball, we're not going to put in number 37 drill and ream for blah, 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 blah. That's referencing number 1, tooling and a manufacturing process. We don't put that on our drawings. It used to be in the olden days, you might find people do that once in a while, but to the ANSI standard, we don't do that anymore. All we want to do is we want to just say, what is the size hole that we need? So you'll find the size of the hole for a number 37. I think it's 0.104, right? Diameter. And that's what you want to put in there. 0.104 diameter through. Done. Okay. And then they can pick if they have something that they want to pick to actually create that hole. Okay. We're not gonna you know, call out tooling or manufacturing process, right? Now it does say in here that we're using a 000 taper pin. Okay. So we need to find the dimensions for that. Now I have Machinery's Handbook here. You can also do a little search on the internet as well. But remember, what's the rule about Googling this stuff? What do you have to do? What was that? Yeah, make sure that you confirm it with another source that you find online, because sometimes you might look, you know, it might look like a great chart and numbers are a little bit off. So make sure you find those very same numbers in at least two places, Now, if you're looking at something like the Machinery's Handbook, now we have some copies here in the lab. I always have mine available and around, but the Machinery's Handbook is a great resource. Now through the program, I don't think we require you to buy it at any point, but it is probably something good to have. Okay. It's not cheap. It's kind of expensive, but it's got like a ton of different information, especially when it comes to like standard size screws, clearance hole sizes, stuff like that. These drill charts, they're all found in here. Different types of fits that we're going to come up against, they're all found in the Machinery's Handbook. But I found where these taper pins are. Okay. So taper pins, as we look at the descriptions here, now I know it might be a little hard to read for those who are virtual, but I'm going to do my best here. So as we go down, these are the pin sizes, and it starts with 7/0. That means that it would be a number 00007 times. Okay. The one that we have called out in our assembly is 3 zeros, which is right here. It's 1/8 of an inch. Okay. It's 1/8 of an inch. So the smallest part, let me move my cursor here. The smallest major diameter here, let me see here. Hold on. I've got my A value and my, where's my B? Well, on one side, my max is going to be 0.126. On the other side, my min is going to be 0.1243. Now, remember, my size going through is 0.104. There's no way I'm getting that pin in. No way I'm getting that pin in. That would be way too much of a press. We do want it to be a slight press, but that's too much of a press. So when I was looking at this 0.000, a number 000, a 30 pin is too big. We need to go with the 40 pin, which is right here. Oopsie. The 40 pin, which is right there. This one makes more sense because its nominal size is 0.09. So that means we've got 5 thousandths nominally of press, which is doable then when we're looking at this. If we're looking at 25 thousandths, that's not doable, okay, with metal on metal. So what you're going to do is you're going to make a pin that on the maximum side is going to be 0.110. And on the minimum side is going to be 0.1083. So it's not much of a taper, but it's a little bit of a taper. Okay. So that's what I did. I'm going to leave this up here. So I'm going to write the numbers down and I'll put it on here. So we're going from 0.110 to a diameter of 0.1083. So it's, again, not much of a taper. And the length that we want is going to be 0.75 inches long. Okay, 0.75 inches long. So we're going to model this and create it. Okay. So I'm just going to kind of leave it up here, make sure that everybody kind of sees our numbers. And then I'm going to bring that down. So what I did was on here, on our assembly, oopsie, other way, sorry, I'm zooming in. Let's go up. On our assembly, we're going to model a taper pin that is going to be a diameter of 0.110 to a minimum on the other side of 0.1083 over a length of 3/4 of an inch. Okay. Now, I already modeled mine. And what I did was I just called it a taper pin for the file name in that column. And then the common name, I made it a number 4 zeros taper pin by 0.75 long. This way, it's a part that you would just order. It's not a part that's really going to be made because this is like a hardware piece, okay? And we're just going to model it. We are not making a drawing for it, but we need to like stick it in. Does that make sense to everybody? So we're just going to model this pin, right? So I'm going to go over to Creo and I'm going to go into my assembly. And before I do, I'm going to open up my taper pin file. So I've got it just called out as a taper pin. That's it. So this is my taper pin part. So it's a create new. Okay. And your file name, your drawing name is going to be taper_pin. And then your common name is going to be what we see right here. Number with 4 zeros, taper pin by 0.75 long. This is the common name of that taper pin file. Any questions about that? Because if this isn't right, you're getting a comment like, go back to the video. Okay. I don't want anybody to have to do that. How do you edit that? We'll look at that in just a bit. So if, for instance, you're like, crap, I saved my taper pin, but I didn't put the common file in. So I'm going to open that up. Okay. I'm going to open it up. And then what you're going to do is you're going to go to File, Manage File, and go to Rename. Click on Rename. Notice taper pin is my file name. Now I could change that at this point, but if you need to add your common name, click on Rename in Session. And now you have the ability to change that common name. Okay. And then it'll populate in the correct part. Okay. Now, this is my pin. All right. So now how did I create this? So I did a revolve. All right. And I'm going to edit my sketch. I did a revolve. And yeah, that's all I did. I did a revolve. So notice that it's 0.75 long. My large diameter here is 0.110. My small diameter is a diameter of 0.1083, as we saw on our chart. And I started on the left-hand side here and created that slight taper. Now this is a revolve, so I had to put my center line in first, and notice that these diameters are over the center line. And once I have that created, I simply hit OK, and then it revolves it around the center for me. I put a couple little chamfers on the end because they will come with chamfers because it's a taper pin. All right. You don't, it's again, not super critical. Not super critical. Okay. Now, once you have that created, I'll just do a quick save on it. And I'm going to manage, delete my old versions. Okay. Got it. I'm going to go back to my assembly. All right. Now back to my assembly. And I'm now going to pull in these two taper pins. So I'm going to go to the model ribbon, assemble. I'm going to go all the way over to the end here. This is just I called my taper pin part. And there it is. It came in. All right. So we'll put it kind of by over here. And I want now my axis and my axis to be in line with one another. So I'm going to do my coincident axis to axis, and there it is. And I'm going to bring this closer. And now I need to place it. Okay, so we need it to be in the inside here, right? So unfortunately, I didn't create it over that plane. I could line the planes up otherwise. So I'm going to add a new constraint. I'm going to push this in here. Okay. And I am going to do a distance from this surface to my axis. And that diameter is 0.75. So this distance is going to be 0.375. Enter. Okay. And it's in. Now it's not fully constrained yet. Dang it. So what I probably have to do is I have to line up the planes. Because actually, if I go over here, yeah, it's a rotational. Look at that rotational axis there isn't locked down. So I'm going to need to show my planes. All right. And I want new constraint. I'm going to grab this plane and I'm going to grab normal to, oh, wait a second, maybe parallel to that plane. There we go. Now I'm gold. Yep. So now it's parallel. I want the planes on those two to be in line or parallel to one another. And now that's in place. So if I go down here, my taper pen will change the appearance. We'll make it green. Okay, we'll do it again. So we get to do it twice up on the top here. See? So I'll pull out, do an assemble, taper pin. Okay. I'm going to bring it up here and over. And we're going to start by doing the axes coincident. This axis to, now again, with those planes in there, with that axis, there we go. So it's in line. And now I want to move it inside. And we're going to do a new constraint, distance. And we're going to go from, and it doesn't matter which side, but I'm just going to go from this surface. So by turning off the planes, I'm going to turn those off. This surface to this vertical axis, and that needs to be 0.375. I don't feel like it did it. It didn't do it. Whoopsie. Cancel. Yes. Let me try that again. Assemble, taper pin. Where are you? So I want to do coincident from this axis to that axis. Perfect. I'm going to slide this in. And I want to do a distance from my edge here to that vertical axis. And I want that to be 0.375. Now it worked. Okay. Not sure why I didn't last time. And then I need to do that plane thing again, where I get them either perpendicular or parallel. And here's the horizontal plane, if you would, of my taper pin. And I'm going to make that parallel to, oopsie, not that one. Remove. We're going to do this one parallel to this one of the handlebar. There we go. And now I turned gold, so I'm fully defined. And I'm going to go down to the bottom and change my taper pin to green. Now I have all of my pieces, hardware, pins, keys, sliding keys, jaws, bases, everything all in place. Okay. Now, the first part of handing this assembly in is going to be the model part here. So this is a screenshot. I'm going to turn off all of my axes and planes. Okay, so it's cleaned up. And then what I'm gonna do, I'm gonna scooch this up. Depending on how large or small your screen is, I want to see all of your parts. So I have to, because I'm on a laptop, I'm gonna get rid of these top portions here. So I wanna see all of your individual pieces, that they do not have any boxes in front, that they are fully constrained. So I'll do my Windows Shift S, or whatever your screenshot method is going to be, include the model tree and your assembly model. Okay. And that is going to be what you're going to upload for the first part of this assembly. So I'm going to do File, Save, and you'll upload that to assignment number, I think we're on 14. Is that right? Is this assignment? Oh no, number 12. Number 12 is the assembly. And then the second part of assembly, assignment number 12 is going to be doing the assembly drawing. Okay. So, so we will be back with more on that. All right. But now the model is complete. Are there any questions before I leave this assembly? Regenerate the model. You're going to be going on the model. You're going to just simply click regenerate. Yep. And then you're going to go File, Save. Then your file save should be okay then. Yep. Yeah. If you get that regenerate error, go to the model ribbon, regenerate up in the corner. It's that simple. And then try to resave. And that usually clears it up. Okay. So if there aren't any questions, I'll stop here and we'll be back with our assembly drawing.